Hello, everyone, and welcome to the day 2 of the MENA Festival. Yesterday was a huge success. We hope you enjoyed it, and if you missed it, you can watch it. You can watch it again on the links that we've sent on Discord, the YouTube links. Some changes are out of hand, so we will be starting today with our speaker Fouad, and the workshop of Dr. Ramzi will be postponed until 2 p.m. Fouad is an AI instructor at Zaka, our community sponsors. Welcome, Fouad. We are so happy to have you with us. Feel free to introduce yourself and begin with your workshop. You can start by introducing yourself.
Thank you. I will start by sharing my screen. Okay, so now all of you can see my screen, right?
Yes.
Okay. So first of all, thank you for joining, and thanks for Beirut AI for inviting me to this workshop. So today's workshop is going to be another topic about COVID-19. So I know that we've all had enough from COVID-19, but today's workshop is going to be interesting. So we're going to be detecting COVID-19 out of chest X-ray images. The workshop that we're going to do today is going to be technical. So we're going to be coding together. Okay, we're going to be building by the end of it a model that would be able to classify chest X-ray images to detect whether a person has COVID-19 or doesn't have COVID-19. Now, for those of you who love programming, it's going to be great. If you don't love programming or if you don't have a programming background, there is no issue because we will be explaining the logic behind of it, and we will be focusing on if you want, why are we doing things rather than how to do them. So it's going to be great either way. Now, before I start, I'd like to quickly introduce myself to you so that you know me better. So my name is Fouad. I'm a computer and communication engineer graduate from the Lebanese University. I pursued my research master's in the technology of communicating medical and industrial systems. So my research was hugely focused around everything related to technology. And because of my passion towards technology and all of its aspects, usually my areas of interest include things like artificial intelligence. Sorry. So my areas of interest include everything related to artificial intelligence, software engineering, and cloud computing. So this is it concerning the academic background. Now, on the professional background, I'm an artificial intelligence instructor at Zaka. I've been with Zaka for over a year now. And for those of you who don't know Zaka or who are not familiar with Zaka, so Zaka is an artificial intelligence company that focuses on giving education and on building the AI ecosystem in the MENA region. We help upskilling people by giving them the necessary knowledge that they need in order to get introduced to artificial intelligence and to apply it in their life. So we have different kind of programs, and based on these programs, you would get introduced to different aspects of AI, and you would get to either apply it in your projects or even have it as a career. So if you're interested, definitely reach out to us and see the programs that we offer. Here's my contact details. So here's my email address and my LinkedIn profile. Feel free to connect and feel free to ask me whatever you want. Now, concerning this workshop, the workshop is going to be organized as follows. I will be starting with a couple of slides where I would be first talking about the problem that we are solving today. So why are we solving this and why do we need this in the first place? After it, I would talk about the goal of this workshop. So what are we going to be building by the end of it? We would see this. And after it, I'd like to just take a step back to introduce one major prerequisite for our workshop, which is how can we do image classification using deep learning? For those of you who don't know, so we'll be introducing this concept briefly. After it, I'll talk about the steps we'll be following to build our model, and then we'll move to the hands-on implementation. So the slides would take around like 20, 25 minutes, and then the rest of it would be hands-on implementation. We have a Q&A by the end of the session. However, definitely I'd like you to ask me your questions while I'm working. So at any point, if there's something that is not clear, if you think I'm going, for example, too fast or something that you don't understand, just feel free to post your question in the chat and I would be getting back to you as soon as possible. So I'd like the session to be interactive. Okay, so let us start by introducing our topic for today. Now, in the introduction, definitely I'm not going to be introducing COVID-19 to you because I believe that all of you know what COVID-19 is. So we've been living COVID-19 since like almost 2 years ago. And I do believe that all of you, all of us actually, we know what COVID-19 is. So the problem is that COVID-19 is actually a highly infectious disease. And this is why, because of this high infectiousness, we should be able to, or we should actually diagnose it the quickest possible. Because when we diagnose a patient the quickest possible, we would be saving a lot of trouble because this person would be like taking the necessary precautions. He would be going into quarantine, let's say, and he would be avoiding to get involved in crowds. And diagnosing COVID-19 the quickest way possible was something very interesting and very high priority, if you want, for governments and for even everyone involved in the medical field. And the most common way of diagnosis that we all know about is the PCR test. And this PCR test, it usually requires, as you all know, minimum 24 hours to get the results. And the problem is that these results, sometimes they might be inconclusive. So sometimes they might ask you to do another PCR test, let's say, etc. And this means that you would be waiting a lot in order to be diagnosed. And here is where the idea started. So if you want, the people that are involved in the medical field, they thought that why don't we leverage the chest imaging, since our disease is a respiratory disease? Because, you know, respiratory diseases, they can be diagnosed using chest x-rays or chest imaging in general. So why don't we leverage this functionality in order to be able to diagnose things a bit faster? So let's say a person has done his PCR test, however, it was, let's say, negative, but the person still had COVID-19 symptoms. So how can we make sure that this person is really testing negative? So this is one way. So these chest imaging techniques, if you want, they operate in addition to the PCR test. Okay, so it's like a way of helping the PCR test in a way or another. So that's where the idea came from. So ideally, what they wanted is that when they look at a chest X-ray, they needed to see whether this person has COVID or not out of this kind of image. So let us just look at these two images right here. And let us take a guess. Can you guess which one of these two images has COVID and which one doesn't have? Just as a guess. I'd like to see your thoughts in the chat if possible. Okay, yeah, you got it right. So basically, image 2 has COVID, and the first image, it doesn't have COVID. How did we know that? So basically, for me, when I first looked at these two images, I was like, oh my God, they are very much alike. So how can I distinguish between the two? Later, after reading and getting into what are we looking at to see which one has COVID and which one doesn't have, we can see that, for example, here in the second image, there is something that is a bit blurry on the lungs, and this means that this is where the COVID is, you know? And here on the right, no, we have the dark stuff. So here there is anything, okay? So this is why we say that here is a COVID image and here is a normal image. The problem might be a bit complex when you are classifying between different respiratory diseases, because respiratory diseases, they don't just include COVID. So we have other kinds of diseases that can be diagnosed out of chest X-ray images. And here's where you might have a bit more difficulty. For the sake of this workshop, no, we're just going to be classifying between the two. That's first. Second, even with this concept in mind, things might get a bit tricky because sometimes you don't have the same brightness, let's say, or the same color distributions in images. And this is where also the images might be a bit trickier to guess. Since this task, as you all know, it requires a human level expertise. So it requires a radiologist to be able to classify these images. Usually, the research community always wanted to use deep learning models in order to be able to achieve these difficult tasks. And if we look at the research that has been done in this area, we can see that there's a lot of research and a lot of papers that aimed to do this work. So they were aiming, even if through different methods, to have models that would receive as input an X-ray image and classify it to see whether this patient has COVID-19 or not. And the research is huge in this area, to be honest. Now, although these researchers and many more have done several models, the common point or the shared thing between them is the following. So they all wanted to build a model, which is going to be an image classifier, basically, that would receive as input an image, and it would detect whether this person has COVID or he doesn't have COVID. That's their goal, and they're always, in the research field, they always want to have like the best model and the highest accuracy and etc. So that was their goal. Today, for the scope of this workshop, our goal is not to address the research problem. No, our goal is to build a baseline model, if you want, and this model you would see that it would be performing well. And the goal is to let you see that doing this kind of things using deep learning is not that hard as it sounds. Okay, so it's going to be easy, it's going to be straightforward, and we will get to be knowing how to build such kind of models and how to make them operate. Okay, that's our goal. Now, in order to build our model, we need to be a bit having a small understanding about image classification, and we need to know how image classification is usually achieved in deep learning. So for this reason, I'm going to just put here a small part where I would be highlighting how do we do image classification using deep learning. So basically, in image classification, our goal is usually to build models, and these models, they should receive as input an image, and they would be able to classify it. So for example, this model receives as input the image of a cat, and it would be able to classify that this is a cat. And this model, it receives the image of a dog, and it would classify that this is the image of a dog. That's the goal of image classification model. Now, for us humans, it is very much easy to distinguish between cats and dogs. Okay, so when we look at the image, we can directly know what does this image hold. However, how does a model know this? So how is a model supposed to understand that this is a cat and this is a dog? So what is the image at the first place according to a model? So the image, as you all know, is just a bunch of numbers. So the image is just if you want, a bunch of pixels, and these pixels have intensities over different channels. So how is a model supposed to understand these numbers to know that this is the image of a cat or this is the image of a dog? Well, the thing is, what you need to know is that the image, in order to be classified, it needs to pass through a certain tunnel. Okay, what is this tunnel? Now we would be dissecting it together. So here I have the image, and here I have the prediction or the meaning, let's say, of this image. What are we gonna have inside of this tunnel? So since here at the very end we have the classification, or what does this image hold? It is a cat. Normally, what we would have by the end of the tunnel is some kind of a classifier, and this classifier is what would be giving me the result, right? That's intuitive. Now, the thing is that this classifier, in order to give me a result, it needs something you know, so normally a classifier would be needing some features to be able to classify something. What are the features that would help a classifier know that this is a cat or this is a dog or whatever? So usually these features, they would be something like the shape of the nose, the shape of the ears, the shape of the mouth, just like the features that we look at when we are looking at an image. So when we look at this cat, we know that this is a cat from these kind of features and even more. Now, the problem that we have here is that how can we actually get to know what these features are? How can we reach a level where we know what these features are? Here, we need another block. This block is going to be the feature extraction block. So this block would receive the image as input, and it would give us the features out of this image. And these features would be fed to the classifier, and the classifier would be able to classify. That's the kind of tunnel that we would be having in order to classify an image. Now, this feature extraction block here, it might seem a bit ambiguous. However, what we really do in deep learning is that we leverage what we call convolutional neural networks in order to do this feature extraction from images. So the convolutional neural networks, they receive the image as input and they do the automatic feature extraction. So they give you a lot of features that a classifier would be able to classify. Okay, so this is the main intuition and the main idea behind it. Now, for me, I'm not going to be diving into how convolutional neural networks work because this would take a lot of time. However, I'd like just to tell you the high level of it. So a convolutional neural network is just made of several convolutional layers, and these convolutional layers are the layers that help you extract features out of your image. So let's look here at the example that we have. Here we have the image, and what happened is that this image is going to be fed to the convolutional layer. The convolutional layer is going to extract features, or it's going to extract information out of this image, and it would pass them to what we call a pooling layer. This pooling layer is going to compress the information, okay, and then pass it to another convolutional layer. The other convolutional layer would also extract information and then pass it to another pooling layer. And this pooling layer would also compress the information and so on and so forth, up until we reach the classification part, which is going to be a fully connected layer, just as what we do in a normal neural network. Okay, so this is it concerning the main idea behind it. This is how we do image classification. Now, before I proceed, do you guys have any questions about this? Is everything clear? Abdullah is asking if it is going to be recorded. Actually, it is. I think it is podcasted on YouTube. Okay, perfect. So now, what will we be building next? So we would be building a model to do this. Okay, do all CNN do the exact same work? Actually, convolutional neural networks, their work is to extract features. You know, that's the different layers. Okay, no. So the convolutional, okay, let me just take a step back to explain this. So the convolutional layer would extract features from an image. However, the pooling layer is going to be compressing this information. Okay, that's so when we reach, for example, the end of the convolutional layers, we would have the maximum amount of information, but also it would be a lot compressed, you know. So here are the two basic kind of layers. So the convolution is going to be extracting information. The pooling layer is going to be compressing it in a way or another. Okay, you're welcome. So now what will we be doing next? What we will be doing is that we will be building our model according to the following steps. So we will start by getting our data in order to be operating. Now, in our case, the data would be living on GitHub. So getting it is going to be easy and straightforward. So nothing to worry about here. After it, we would start by inspecting the data. And by inspecting, I mean getting to know our data, what is what numbers are we dealing with if you want, what is what does our image يعني, look like in a way or another. After it, we would be building our model according to this data that we have. And finally, we would be evaluating the model. And by evaluating, I mean seeing how this model is operating on unseen data or on data that it hasn't seen before. Okay, so these are going to be the steps that we will be following. And now we would be moving to the actual hands-on. Before we move to the hands-on, I'd like just to tell you that this is going to be it's going to be hands-on. So we're going to be coding together. Okay, I would be sharing with you now the links that you can use in order to code along with me if you're interested. And if for some reason you don't want to code with me, then this is just fine. You can just watch me do things, and whenever you have something that you're not understanding or you're struggling with, definitely ask in the chat and I would be getting back to you. Okay, so what I would be doing now is that I would be sharing with you this GitHub link, and this link, it holds the repository for the dataset and for the code also. I'm gonna paste it in the chat. Now all of you, you should have access to it, I believe. Now, as you can see here, we have here the data set. No need to download anything, by the way, okay? Everything will become clear in just a minute. So here you have your data set. If we scroll down a bit, we can see that here we have the link to the code that we would be filling together, okay? And here we have the solution. So definitely for the scope of the workshop, go with the blanks and you would have access to the solution even afterwards. So don't worry. Okay, so what we'll be doing is that I'm gonna be clicking on this link to go to this tab. Now, what we'll be doing is that we would be using the Google Collaboratory in order to build our model. And for those of you who are not familiar with what Google Collaboratory is, Google Collaboratory is just, if you want, Jupyter notebooks, however, running on Google servers. Okay, so the beauty of it is that you don't have to install like pretty much anything. Everything is already there, so you can build your models without worrying about the libraries that you have, and it's going to be easy and very straightforward. Okay, so yeah. Now, the first thing that you would do when you enter on this link is to make sure to make a copy to your drive. Why you should make a copy to your drive? Because if you don't make a copy to your drive, your work won't be saved. Okay, so everything that you work won't be saved. However, if you make a copy to your drive, this means that this notebook is going to be copied on your personal drive, and after finishing the session, you would always have access to what you have built. Okay, so after making a copy, the name here would change to copy of blanks, etc. And now we should be good to proceed. Okay, so I will start with the first step that we will do is to import some of the basic libraries that we would be using for our workshop for today. So the first library that we would be using is the NumPy. The NumPy library is just the library that deals with matrices, vectors, etc. So since we are dealing with images, we're gonna need this library. We have the matplotlib library, which is gonna be used in order to plot things and visualize some stuff. We're gonna use the TensorFlow library in order to build, if you want, our neural networks, because you know TensorFlow is like the most common framework to build neural networks. And you have here the CV2 library, which is the OpenCV library that is used to deal with images. And we would import also the random module just to be able to, if you want, generate some random numbers later. You would see why we would be using it. So let me hit on Shift Enter to run this cell. So the first thing, it's going to take a bit time here to initialize and load, etc. After doing this, everything would be working just fine. Okay, now we have imported some of our libraries. Now, the first step that we need to be doing is to clone the GitHub repository where we have our data set. Okay, so this is the link for the GitHub repository. It is here. How do we do this inside of Google Colab? We just write git clone, okay, and we paste this link and we hit on enter. And this would bring this repository that we had here, this repository, it's going to be brought to our environment. What does this mean? Sorry. Okay, so what does this mean? Let me tell you what this means. So after cloning this GitHub repository, if we go here over to the files, we can see that we have a folder that is named COVID-19 detection using X-ray images. So this is the name of our repository. If I expand it, you can see that here I have the data set that I had here, you know? So it's like taking what's inside of here and putting it in my environment so that I would be able to use it, right? So that's the goal. Now, as you are seeing, the data set that we have is in a zipped format. However, in order to get access to the images that are inside of it, what we need to be doing is that we need to be unzipping it. Okay. So how can we unzip a data set? So what we will be doing is simply writing unzip, and we're going to be providing the path of the folder that is going to be unzipped. What is going to be this path, if you want? So I just go over to this dataset.zip, and I hit on the three dots that are right here. I hit on copy path. This would copy the path of this dataset, and I just paste it over here. I hit on Shift Enter, and you would see that it is extracting the images that are present in my dataset. Now I hit on refresh, and as you can see, I have now another folder that is called dataset. This folder is going to contain the dataset that I have. So now I am free to start working and seeing what does my dataset look like. Okay. So if we just observe this dataset, you can see that we have three folders inside of it. And what do these three folders mean? These three folders, they just mean that my dataset is divided between three subsets. What are these three subsets? So I have the training, the validation, and the testing. The training subset is going to be used to train our model. And what do I mean by train our model? Train our model, it means that my model would be able to recognize that this image belongs to a person who's infected with COVID, and this image belongs to a person who is not infected with COVID. Now, the validation set is going to be used to tune our model. And what do I mean by tune? I mean that it would tell me how, let's say, some set of hyperparameters are affecting the performance of my model. The data and the validation is the data that the model does not see, but I use it to compare different sets of hyperparameters to see which one works best. And the testing data is just going to be data that the model doesn't see since the beginning. It doesn't see it at all, and we're going to be using it to if you want to see how my model would be like performing in general in real life to get this this idea out of it. Okay, so this is the basic idea of having these three sets. Okay, now if I need to expand these sets to see what they really hold, if I expand, let's say, the training set, I can see that it holds two folders. One of them is the COVID folder, and one of them is the normal folder. The COVID folder would hold the images that are related to COVID-19 infected patients, and the normal folder would hold the images that are related to people who are not infected with COVID. Okay? Now, the same thing would be in the testing subset, and the same thing also would be in the validation subset. Now, this hierarchical division, you would see later that it would be very beneficial for us in order to be able to train our models and, if you want, the easiest possible way. So once we are dealing with the classification problem, guys, if you want, divide our data set with this hierarchical structure, things are going to be very much easy for us. Okay. Now, what we need to do, guys, is that I need to have a specific kind of information. What do I want to do now? I want to know how many images do I have in my training set, in my testing set, and in my validation set. And not only this, I need to know how many images do I have that belong to COVID persons, let's say, in my training set, and how many normal images I have in my training set, okay? So I need to know, if you want, the exact number of images of each category inside of each of my subsets. That's what we need now to be coding, the first step. So in order to do this, normally, what would someone do? So imagine that you have these folders just on your computer. What would you do in this case? What you would do normally is that you would go inside of this training folder, let's say, go inside the COVID folder and observe the count of the images that are inside of it, you know? And the same thing would happen for normal images. What we would be doing in Python is going to be just the same thing, okay? However, it's just going to be with one line of code to automate the whole process, okay? Now, the first step is going to be to specify the training path, the validation path, and the test path. How do we specify these? I just go, for example, here to the training. I hit on the 3 dots, and I copy the respective path, and I just paste it over here. I do the same for the validation and the testing. Okay, and I hit on Shift Enter. Now I have my training path, my testing path, and my validation path. Now, what we need to be doing is that we need to be counting the number of, let's say, COVID images inside of the training path and the number of normal images in the training path. So the first step is going to be for the training path, okay? And the other sets are going to be very similar. So once we do this training path, the others are going to be just straightforward. So how do we do this? So as I mentioned, what we normally would do is that we need to go to this, let's say I'm counting the COVID samples. What I need to be doing is that I need to go to this COVID folder and count the number of images that are inside of it. How do I do this in code? So let's code it together. First thing, I need to go to the COVID folder, right? How do I go to the COVID folder? I use what I call the OS library. The OS library is just a library that automates some of the operating system commands so that they would be done in an easy fashion. So I use the os.path.join, and I pass in my training path, okay, along with what? Along with COVID. What does this do? This would give me the path of my COVID folder, okay? So I have my training path over here, and I added to it the COVID, and this would mean that now I am inside of this folder. Now, the second step is going to be to list what's inside of this folder. So I'm going to see what are the images that are inside of the folder. And to do this, I'm going to use the os.listdir, which is going to list what's inside of this particular directory. And after listing what's inside of this directory, what do I need to do? I need to count the elements in this list, right? So how do I count the elements of a list in Python? I just use the len function. So to repeat, what did we do? We are just going to the COVID path, and we are listing what's inside of it, and we are getting the lengths of the elements that are inside of it. So this would give me the number of images that are within this particular folder. Now, the next, the same thing would happen when we are dealing with the normal images, right? So I'm going to just be pasting this over here. But instead of using COVID, I'm going to this time be using normal, and I'm going to be hitting on Shift Enter. So we would see that we have 200 COVID-19 images and 200 normal images in our training set. So this means that we are dealing with a balanced data set, which is very good for the model that we'll be building so that the model won't be biased towards a particular class or whatever. Now, before I continue, guys, do you have any questions about this? Is anything unclear? Am I going fast? Am I throwing a lot of information? Just tell me. Okay, awesome. Okay, perfect. So now what we need to be doing is to do the same thing, but for our validation set. So we need to be counting the number of COVID images and the number of normal images in our validation set and in our testing set. So what I will be doing is that I will just be copying, because it's going to be almost the same. However, here we would be just changing, instead of training path, it's going to be the testing path. Sorry, here validation. Okay. And the same story would happen here with the normal images. I'm going to hit on Shift Enter. And you will see that in our validation set, we would have 50 COVID-19 images and 50 normal images. Okay. Now, the same story would happen with the test set. So let me just, okay. Let me just paste these lines here. Okay, here I would be changing this to testing. And here as well. And as you can see, we have 25 images in our testing that are for COVID-19 infected patients and 25 images that are belonging to normal people. So this is concerning the shape of our data sets. Okay. Now, can we do the code on PyCharm? Yes, definitely you can do the code on PyCharm. However, as I mentioned before, the interesting thing about the Google Collaboratory is that you don't have to install a lot of libraries. All of them, they are already embedded. So it's good for this reason first. And second, you would be able to write some documented code. So as you are seeing, I can just write some text over here to explain what I am doing. Okay. In the testing set, the first one should be COVID. What do you mean? Oh, yeah. You're okay. Thank you for the, yeah, thank you. Thank you. Okay. So yeah, now guys, what we need to do is that we need to be visualizing our images in a way, okay? How can we visualize these images? I will start with, now for what we'll be doing is that we'll be now focusing on the training set, okay? So I need to be visualizing some images that are related to COVID-19 patients and some images that are related to the normal people. So I will start with COVID images, okay? How do I get all of the images that are related to COVID? So inside of this folder here, I have a lot of images, okay? If I just expand it, you can see that I have a lot of images. However, what I will be doing is that I would be selecting randomly out of those, I don't know how many images, I would be selecting just like 5, and I would be displaying them just to get an idea what does an image related to COVID would look like, okay? So for this reason, what I would be doing is that I would be, okay, yeah, 200, exactly. So what I would be doing is that I would be first getting all of the images that we have in our COVID folder right here, and I would be selecting out of them 5. How do I get all of the images? So this is something that we answered previously, by the way. I answered it here. So we're going to be listing what's inside of the COVID directory. Okay, this is how I do things. So let me actually just copy it from here because it's going to be the same. Okay, and I'm going to be pasting it over here. So we are listing what's inside of this particular directory. Now, to give you an idea, what are these images or what does this return to me? So this gives me the individual names of the images, okay? So this is the name of a particular image. And here we have 200 images, as Roy mentioned. Now, what I need to be doing is that I need to be selecting out of these images just 5 to show them. Okay, we can select as many as we want. So how can I select 5 images? What I do is that I use the random.sample function, and I pass the all images, did I call it? Yeah, all images and 5. So this would give me 5 names out of all of these names that were above, and I hit on Shift Enter. For example, these are the 5 names that it sampled randomly. Now, what I need to be doing is that I need to be visualizing these 5 images. How can I visualize these 5 images? I need to be visualizing them next to each other, okay? This is what I would be doing. How do we do this? So the first thing, I would be creating a new figure, and I would be using the matplotlib library to do this. Now, what I need to be doing is that I need to be iterating over this list of images. And for each of these images, what I need to be doing is to first specify the image path. Where is it located? After it, I would be reading this image, and then I would be displaying it. That's in brief. How this is done? So the first thing, I need to get the image path. How do I get the image path? I just use the os.path.join. What do I need to join in this case? I need to join the training path, right, with COVID, since we are dealing with COVID images, with the image name. What is the image name? It's going to be image name here, because we are iterating over things. Okay, so here, guys, I use the enumerate. What does this enumerate do? So here I have these, if you want, names. When I say here enumerate, it gives me, for example, 0 for this name, 1 for this name, 2 for this name. Okay, so it's just giving them an index. This is the index, and this is the image name. So I'm joining the training path to the COVID folder to the image name, and this would give me the path of the particular image. And now I need to be reading this image. Okay, I have the path, I need to read it. How do I read it? I use the mread function, and I pass as a parameter the image path that we had. Okay. Now I read the image. Now what I need to be doing is that I need to be visualizing the image. Now, one thing, I don't know if you know it, but when we are visualizing several plots next to each other, we use what we call the subplots, okay? Now, in my case, I am visualizing 5 images, and these 5 images are gonna be organized as follows. I'm gonna have 1 row, okay, and 5 columns. So these are the first 2 parameters of a subplot, the number of rows and the number of columns. And the last parameter is going to be just the number of the image. So the first image is going to have number 1. The second is going to have number 2. The third, number 3. So in our case, it's going to be the index of these images plus 1, because the index, it starts with 0. However, we need to start from 1. So here it is the subplot, and then I am showing the image, and I'm putting a specific title to it. So let me just run this cell to see the output. So guys, as you can see, let me close this. Okay. So guys, as you can see, here we have some of the COVID-19 related images. Okay. And this is our subplot. So 1 row, 5 columns. This is the image 1. This is the image 2. This is the image 3, etc. Okay. So this is how we do the visualizations. Now we will do the same thing for the normal cases. Okay. So what we need to be doing is that I need to be getting all of the images. So os.list_dir. I'm going to list what's inside the directory. Which directory? It is going to be the training path. And I would be adding to it the normal. Okay. Now, the display images, I'm going to be displaying 5. So I'm going to be randomly sampling out of the list that I have. So I'm going to be using random.sample, and I'm going to pass all images, and I'm going to be passing 5. Now, concerning here, this part, I'm just going to be copying it from here and changing COVID to normal so that we can save some time. Okay, because it's just the same thing. So here it's gonna be normal instead of COVID, and here the title also, it is gonna be normal instead of this, and I'm gonna be hitting on Shift Enter. Okay, there is a typo here. And these are my normal images. Okay. Okay, thank you guys for the comments. This proves that you are following along with me. So this is good. So here are our normal images. So as we can see, this kind of proves what we were saying in the slides. So when we have usually COVID, we have something that is a bit blurry on the lungs. However, when we have normal things, it's not that blurry. So for me, for example, I think there are some cases where things are not that straightforward. So for example, this one or this one, for example, they can be mixed together. However, yeah, this is basically it. Now we are done, guys, with the data-related part. Does any one of you have any question about it? Anything that is unclear? Okay. Okay, perfect. So now, guys, what we need to be doing is that let's yes, sure, you can ask. Didn't change? Yes, it did. So look, the all images here, in the normal cases, what we did is that we joined the training path to the normal. So this means that we are getting inside of this folder right here. So when we have all images, these are going to be the all images in the normal case. However, when we were in the COVID case here, the all images, just let me get to it. The all images, we joined the training path to the COVID. So we are inside of this particular folder. And so these are the names that you would be obtaining. Okay. Any other questions? Okay. I'll assume no. So guys, you're welcome, Simon. Now, what are we gonna do now? So guys, now what we have is that we have dealt with our data, if you want. Now we need to build the model that is gonna be taking, if you want, information out of this data. The model that we will be building is gonna rely on convolutional neural networks. However, as I mentioned before, I was not diving into the details of how a convolutional neural network operates, okay? And how it operates, I mean mathematically how it operates and what are the operations that are involved inside of it, because this is out of the scope of this workshop. So the high level understanding that I told you about while working over the slides is just what you are gonna need, okay? Now, In order to build our convolutional neural network, so here I'm gonna be having several parameters that you're not gonna be responsible to understand. If you already know them, this is fine. If you don't, then this is not a problem. Okay, so we won't be using them. Now, what I need to be doing is that I need to be building the architecture of my model. The architecture of my model is going to be sequential. So sequential, this means that it's going to be having different layers that are stacked, if you want, one after the other. This is what we mean by sequential. Now, the layers that I'm going to have are going to be, as I mentioned on the slides, are going to be, if you want, convolution to extract features, pooling layer to reduce the information, then convolution to extract information, then pooling, and so on, so forth. After it, as I mentioned, we move to the fully connected layers. And how do I move to this? What I need to be doing is that I need to be flattening the layers. How can I, what does this mean to flatten? To flatten is that when you have a high dimensional vector, when you flatten it, it means that you are transforming it into one dimensional vector. Okay, that's what you are doing in flattening. So when we have a one-dimensional vector, it is easy to feed it to a normal neural network that has normal layers or normal dense layers. And this is what we are doing. So we flattened here, we have here a flattening layer that would just transform everything to one, if you want, one-dimensional vector, let's say. And here we pass it to the dense layer, and here is our normal neural network, if you want. This is the normal classifier that we talked about. Okay, so we have here 64 neurons, let's say, and our final layer would be having one neuron to do the classification. And this particular layer is going to have the sigmoid activation function. And for those of you who don't know, the sigmoid just gives you a number that is between 0 and 1. If it is closer to 0, then this means that this person doesn't have COVID. And if it is close to 1, this means that this person would be having COVID. So this is the first thing concerning the architecture of your neural network. At a high level, this is how things are. Here, the numbers or the numbers that we have here or the parameters, don't worry about them because this is not your responsibility for now. We didn't explain it and we won't be explaining it. Now, one thing I need you to take into consideration is that when you build your model, you need to have a predefined input shape. So your model cannot deal with images that have varied sizes. Okay, so your model is going to be dealing with images, and the images are going to have a fixed size. And this would mean that whenever you are passing an image to your model, you need to have this image on this particular size, so that your model would be able to take it as input. You can't have varying input sizes. That's the goal of it. Here we have we have chosen the 128 by 3. What were the shapes of our images, by the way? We didn't do this. So actually, in your case, if you go to the documentation of the data set, you would see that the images have fixed sizes, okay? So how can I get the size of the image? Let me just add a code cell right here. Here I have an image variable, so I'm gonna be using image.shape just to show you. So our images that we have already, they are having this shape, 299, 220, 299 by 3. And what we need to be doing is that our model is not going to be operating on this size. It's going to be operating on a smaller size. When you have a smaller size, usually, okay, you have less information. However, you train faster. And for the scope of the workshop, of a 2 hours workshop, you need to train faster, usually. So this is why we reduced the size. So just keep this idea in mind. This is it concerning the structure of the model. Now, to see what layers do I have inside of my model and how are these layers stacked, I can use the model.summary function here. Okay, so the model.summary function is going to give me a summary of the layers and of the parameters and of a lot of things inside of my model to get, if you want, a better intuition on how it is built. So let me just run this cell. Okay, so if we just need to look at these, what do they mean? So here you have the layer name, which is, for example, a convolution. And here you have the output shape. Now, for now, neglect this third dimension, okay? This third dimension, just neglect it. We gave our model, let's say, images that have 128 by 128. The output of the first convolutional layer was 128 by 128. So it was like the same size if you want, okay? However, this is information. So these are features if you want, okay? Now, this information is passed to a pooling layer, and this pooling layer reduced the size, you know, as you can see. After it, they passed through another convolution, and this convolution, it preserved the size that you had. However, it extracted, if you want more information, and here you have the information, by the way. Okay, so here you have 32, let's say. After it, you compressed this information, so the sizes have decreased, as you can see, 32 by 32. Then you passed it through another convolution to get extra more features, extra more information, and then you compressed them together. Okay, so here's how you can see the sizes that are doing the exact same thing that we were mentioning since the beginning of the presentation. And now after it, you would see it even a bit better. Now after it, you have the flattening layer. The flattening layer is just going to take this the output of this particular layer right here, and it's just going to multiply these. So if you multiply these three numbers, you would obtain this number. And this is going to be your one-dimensional vector. So you are changing from this multi-dimensional vector that you had to this one-dimensional vector, okay? And this one-dimensional vector is going to be fed to the normal neural network that operates. And you know, normal neural networks, they have their dense layers. So I have a dense layer of 64 neurons. And finally, I have another dense layer that's going to be doing the classification part. Okay, so this is it in a nutshell, if you want. Now, if I need to be visualizing my model, because I know that if you don't know convolutional neural networks, you might not be able to grasp what do they do like directly. So this is why I needed to visualize your model in a better way. And in order to visualize this model in a better way, we will be using the visual Keras library. And this library, it just shows you the form of your model in a more visually pleasing, if you want, manner. So the first step that I'm gonna do is to install this library, because this is not one of the built-in libraries that you can just import. So here you need to be installing it. However, since the installation is happening on the Google servers, it's gonna be very quick, as you will see. So yeah, it's now installed. Now, what we need to be doing is that we need to be importing this visual Keras library, and we will be passing our model as a parameter to see the layered view of our model. The layered view, it means that I need to be seeing the layers inside of my model, okay? And here, what we have is just a bunch of parameters that would control the size of the output image that you're gonna have. So let me run this cell and you would understand what I mean by this. Okay, so this is the shape of my, this is actually the shape of my model, okay? What does this shape mean? Let me just annotate a bit. Okay, so this is my model, okay? This model is gonna be receiving an image as an input. This image is gonna first pass through this convolutional layer right here. This convolutional layer is gonna extract information. This information that is extracted is gonna be compressed by this layer right here, okay? Now, this compressed information is going to pass through another layer that would extract more features out of it, which is this one. And after extracting further information, I'm going to be compressing this information even more. Here, I'm compressing it. After it, I need to extract further information. So you know the end of the story, I guess. Okay, here I extracted, and here I just reduced or compressed this information. After compressing these information, now I move to the flattening layer. So this flattening layer, what it did is it's just that it changed this multi-dimensional vector, if you want, to a one-dimensional vector. Okay, this is what it did, the flattening layer. After it, I fed it to the dense layer, the first dense layer, and this is my next dense layer that's going to be giving me the actual prediction. So it's going to be 0 or 1. Okay, so I think this would clarify your thoughts about the convolutional neural networks in general. And yeah, so we have a question. We always see that the normal neural network after the CNN is simple. Is that because that CNN extract the requested information that facilitate the classification processes? Exactly. Because Ahmed, if we don't do this feature extraction, normally you would be dealing with the other way around, where you would be sending each of your pixels to your neural network, and this would teach your model to operate on individual pixels rather than on information inside of your image. So the convolutions, they take your image as input and they extract information. Once you have information and not image, image contain information, by the way, but when you just take this information and know what are you classifying if you want, the job of the normal neural network that comes after the CNN, it would be definitely very much very much simple, because the CNN, it extracted these features so that if you want, the normal neural network part at the very end would be doing its job in a great way. I hope I answered you. Okay, you're welcome. Okay, guys, so this is it concerning the model. So now what do we have? So let me just annotate a bit. So now, guys, we have our data. Okay, we have dealt with our data, and we have built our model. Okay, it is built. Now, what I need to be doing is that I need to be getting my data, I need to be getting it to my model. Why do I need to do this? Because my model needs to be trained, right? And in order to be trained, it needs data, and it needs to be validated and evaluated. And in order to do any of these tasks, I need data, you know? So now I would be figuring a way out, how can I get this data to feed it inside of my model? The first challenge that we talked about before is that our data is just like 299 times 299 times 3. Okay. However, our model is supposed to deal with images that are 128 by 128, right? So this is the first thing that we need to do. So we need to be changing the size of the images so that they can be fed to our model, because our model, it operates on this size. We cannot feed it this size. The first thing, we need to be changing the sizes of the images. This is one. The next thing that we would be doing is that, as you might know, images, they have pixels, right? And these pixels, they have values. Now, the values of these pixels, normally they are between 0 and 255, okay? Now, the thing is, your convergence or your model would be trained faster, and it would be trained better if the images, or if the pixels, if you want, they have a smaller range of values instead of having 0 to 255, because you would be dealing with large numbers. And this is why these 0 to 255 gonna transform them to be between 0 and 1. Okay, this way your model would be learning better, faster, etc. Okay, now how do we usually do this? We just divide by 255, as easy as this. Okay, so there's no problem with this, but these are mainly the two steps that we would be that we'll be actually focusing on in order to operate. Okay, how do we do these two changes? Well, luckily for us, we have a library inside of library inside of Keras that helps us deal with these images. Okay, and it helps us pre-process, if you want, images before feeding them to our models. And we do this in the easiest possible fashion. Okay, so we won't be struggling in order to do these changes, and even other changes that we won't be talking about inside of this workshop, definitely. But this particular library, guys, it really facilitates working with computer vision models, and you would do things with the easiest possible way. So we're going to be using the Keras preprocessing.image library, where we have inside of it what we call the image data generator class. This image data generator class is just a class that would help getting your images and do some transformations on them. Okay, so you have your images, you have your data, and you need to do some transformations on them. So how do you do this? You do this using this particular class. So the first thing that we need to be doing is rescaling, right? So all of the images that we have, we need to be rescaling them. And by rescaling, I mean having their values between 0 and 1 instead of between 0 and 255. So the first thing that we do is that we create an instance of this image data generator. And inside of this instance, we pass the parameter, which is the rescale parameter. This rescale parameter is going to be 1/255. And this means that each of our pixels will be divided by 255, so that the values inside of them, they would be between 0 and 1. That's the first thing. So here we define an object that would do this. Okay, we still did not do anything to our images, by the way, but we just defined the object that would do this. That's the goal. Now, what we need to be doing, just like in any machine learning or any deep learning problem, you need, in order to train your model, you need to have training data and you need to have a validation data. So here, luckily for us, this data generator object, it can get this training data for us from our directories if they are organized with this way. I repeat. So if we organize our data set since the beginning with this hierarchical format, training, inside of it, each folder contains a class. Testing, inside of it, each folder contains a class. So if we organize our data set using this hierarchical structure, getting the training data is going to be very easy. So what do? I use this object, which is the data generator object, because it's going to be generating our data, our training data, if you want. This data generator is going to take our data from a particular directory. In the training case, what is this directory that the generator is going to take data from? It's going to be just the training path that we have specified since the beginning. Okay, so here I specified the training path. This means that the data generator is going to take my data from this training path. Now, my data, in order to be fed for a model, it needs to have a specific size that we have specified at the beginning, which is 128 by 128, right? So the target size is going to be, okay, is going to be 128 by 128. That's the target size. And the class mode, it indicates how many classes am I dealing with. Okay, so how many classes do I have inside of my problem? In my case, I have 2 classes. So I am dealing with a binary classification. So I just write here binary. Okay. Okay. Now, this is it concerning the training generator. Now, concerning the validation generator, is just the same thing. So nothing has changed, except that I need to be taking this data generator object that I have created before. It needs to take the data set from another directory. What is this directory? It's going to be the validation directory, right? So for this reason, I'm going to be passing over here the validation path that we have specified at the beginning. The target size that we have is going to be also 128 by 128, because this is the size that our model is meant to be dealing with. And also the class mode is going to be binary because we are dealing with a binary classification. So now, until now, I haven't fed the data to my model. Once we feed the data to our model, you would have the full picture if you want. Okay. So now let me run this cell here. Okay. You would see that this training generator, it found 400 images belonging to two classes, which is right. Okay, because we already have mentioned that we have 200 COVID images and 200 normal images in our training set. And the validation generator, it found 100 images belonging to two classes. And also this is right, because we have already mentioned that inside of our validation folder, we have 50 images for COVID patients and 50 images for normal patients. Okay, so this is right. Now let us see what are the indices that our generator in general assigned to the classes. So for this reason, we're going to be using the class indices to see. Let me just run this cell. Okay, a great question that I have now on the chat, because this is now what I would be doing. So actually, if we just look at the class indices here, we see that it assigns them automatically. This is one good thing, okay? In our case, we can see that it assigned COVID for 0 and normal for 1. Why did it do this? Because it just operates on alphabetical order, okay? So C comes before N, and this is why COVID got 0 and normal got 1. However, if we need just take it to link things to how life functions, in life, a COVID-infected patient is positive. So it makes more sense to have it as a 1, you know? And the normal patient is negative, so it makes more sense to have it as a 0. And for this reason, what we need to be doing is that we need to be specifying these classes for the generator. If we don't, then it assigns them randomly. And most of the problems, this won't be actually a problem. But in our case, just to, if you want to make things more close to the reality, this is what we will be doing. So here I specify classes if you want. And they're gonna be, if you want, normal is gonna be the 0, okay, and COVID is gonna be for 1, and the same thing would happen. Let me add here a comma, and the same thing would happen here, right? Let me run this cell. So now, if I just look at the indices that it generated, now I have the COVID, which is 1, and the normal, which is 0, and this is how reality functions, as you know. Okay, so that's just as a note. So now we have this generator that would generate our validation data, and we have this generator that would generate our training data. Why do we need Aslan to generate them? We need to generate them just in order to train our model. Okay, this is the goal of it. Now, how do we train our model? So before training our model, what we need to be doing is that we need to be compiling our model. And what do I mean by compiling? By compiling, I mean to specify how this model would be trained. If I want to say something, so when I am training a model, what am I really doing? When I say I'm training a model, what am I really doing? What I'm actually really doing is that I am minimizing an error. When I am training a model in a supervised learning fashion, I am just minimizing an error between the predicted labels and between the actual labels. That's what I am doing. I'm just minimizing this error. I'm minimizing this loss, okay? Because the error, we refer to it as a loss. So what I am doing is that I am minimizing a loss function, okay? And this is what this loss function refers to here. So I am minimizing, in my case, since I have two classes only, I am dealing with a binary classification problem. The loss is going to be a binary cross entropy. There are other losses, by the way, that we can investigate with, but this is just one of them. So my goal is to minimize the loss when I am training. How do I minimize this loss? I need an optimizer to minimize this loss. I need something that optimizes this loss. And what is going to be this optimizer or this algorithm? So there is a lot of algorithms. So there is RMS prop, there is SGD. So here I am using Adam as an optimizer. And while optimizing or while minimizing this loss using this optimizer, what are the metrics that I am looking at? I am looking at the accuracy metric to know whether I am doing good or I am not doing good. Okay, so this is the goal of the compilation, if you will. Now, after it, I need to be fitting my model. And this is the actual training, guys. Okay, what do I do when I am fitting my model? So as you all know, I train my model on the training set and I validate my model on the validation set. Okay, and I usually I do the training for a specific number of epochs so that the model would be learning more, if you want. Okay, now the good thing that we have is that we have already defined some training, a training generator and a validation generator. And so this training generator can get directly our training data in a labeled way, okay? And the validation generator also can do this, just because we defined them using this particular function, and just because our data was divided using this hierarchical structure. So now I need to pass here, usually when I fit a model, I need to pass my training data. And here, what I need to be passing is just my train generator. And this means that when I'm training, okay, it is taking, this generator is taking the data from the folders that I already have and feeding them to the model so that it learns from them. Okay, this is what's interesting about it. Now, the validation data, also, we have the same story. So what we need to be doing is that we need to be giving it as a parameter, just the validation generator. What did we call it? Val generator. Okay, sorry. Val generator. Okay. So this means that while it is training, it would take this validation data in order to see how well it is doing, what's its accuracy, etc. So this is it. Now, the number of epochs is going to be, so for how much long are you going to be training your model? So for how many epochs? Usually we can train for as many epochs as we want. Of course, there are some limitations. Now, in our case, I'm just going to be training for 5 epochs for the sake of the time so that we can get something in a fast way. But definitely we can train for longer and reach even maybe better results. I don't know. Okay, so let me just run this cell and you would see your model will start training. It would take like around, I think, 1 minute, not more. Will the accuracy increase or decrease if we increase the epochs for the data that we have? Okay, actually, this is a good question. And this is, if you want, a broad question. So if you increase the number of epochs up until a specific limit, let's say, your accuracy will keep increasing. However, after a certain limit, your accuracy might start to decrease. And this is where you would reach what we call in machine learning and deep learning overfitting. Okay, and for this reason, the number of epochs is considered as a hyperparameter that you tune. Okay, so let's say I started with 5 epochs here, and I thought that I am maybe overfitting in a way or another. This means that I need to be reducing this number of epochs so that I don't overfit. Okay, so you can increase it as long as you are not overfitting. In other words, you can increase it as long as your accuracy is increasing. However, when you see that your accuracy is starting to decrease, then no, you cannot continue. So you stop at this point. Okay, you stop at the point where your accuracy starts to decrease. This is where you stop. So you can increase it up until a limit. I hope I answered you, and I hope you understood. Okay, awesome. So this is it, the training. So as you can see now, we have good accuracy. So what interests us is the validation accuracy, because this is the accuracy for the set that the model is not saying while it is training. Okay, and we have 95%, which is good. And now let's say I didn't have this accuracy and the metrics that I had or the results that I had were not satisfying enough. What do I usually do? What I do is that I need to change some parameters. So let's say I need to add an extra layer, remove a layer, maybe let's say change the loss function here, change the optimizer, maybe train for a longer number of epochs, reduce the number of epochs. So there's a lot of things that I can do. And all of the things that I am doing, I can monitor their effect through this validation accuracy that I am obtaining. And this is why, guys, I mentioned to you at the beginning that the validation data, its goal is just to help you tune your model, because you can see the effect of the hyperparameters that you are specifying on it. Okay, so this is the goal. Now, in our case, it is already reaching something good, and we don't have much time, so I'm not gonna be going more with it. So we're just gonna stick to this one, but just for you, if you want to improve the model for later, this is what you should be doing. You should be monitoring the validation accuracy and accordingly changing some of the hyperparameters of your model and retraining and seeing the effect on the new validation accuracy. Okay, this is it. Now, after we have trained our model, okay, so just tested the 10 epochs and got 99% validation accuracy, and this is good. Yeah, exactly. So actually, just let me clarify something. So the data set that we are dealing with is an educational data set, and an educational data set is usually something that is good, and you can reach high numbers when using it. Okay. And this, let's say, 99% accuracy, definitely you would be able to reach it. You know, yeah, this is the case. And if you maybe, I'm not sure, maybe if you train even for longer, you would see that your accuracy would start to decrease because you would be overfitting, maybe. But since this is an educational data set, so I'm assuming the if you want, the distributions are always the same between training, testing, and validation. So it won't be difficult to reach these high numbers. However, if you are, let's say, dealing with real life data sets where you have, like, I don't know how many thousands or hundred thousands of images, this would become a bit more complex. But definitely on 10 epochs you would reach this. Can you please share the link to the Google Colab and the dataset again? I wasn't here at the beginning. Yes, definitely. So I will share with you this GitHub repository link, Eli, and inside of it, you have the link to the collabs. Okay, so you have the link to the code and you have the link to the full code. So this is the blanks that I am filling now, and this is the full code on the collab. So let me paste this in the chat. You're welcome. Okay, so so now this is good, guys. Okay, so I should proceed now with the evaluation of your model. So now, guys, I have trained my model. My model is doing good. I need to be evaluating this model. What do I mean by evaluating? I need to be seeing how my model is operating on unseen data. And what is this unseen data? This unseen data is just the testing data that I have here. So how can I get it? In order to get this testing data, again, the same exact thing that I did with the training and with the validation. So I need to be creating a test generator. This generator is going to take my testing data from this directory, and it would have these specifications. Here I am putting the shuffle to false. It doesn't influence anything, by the way, here. However, this would help me plot the confusion matrix later. Okay, so now just neglect it. When we reach the confusion matrix, you would understand why I did not shuffle things. Shuffling is it means that shall I take the samples by order or not by order? Okay, but nothing would really differ because you are testing. Okay, so let me just run this testing generator. So here we found 50 images that are belonging to two classes, which is something that we already know because we have already spoken that inside of the testing folder, we have 25 images belonging to COVID infected people, and we have 25 images that belong to people that are not infected. Now, in order to evaluate my model on this generator, again, things are very much easy and you don't have to specify anything just because of the hierarchical structure that you specified at the beginning. And this is what I'm trying to tell you. So when you have this hierarchical structure, everything would be very much easy to deal with. And in order to evaluate my model on a particular set or on a particular generator, I just pass here the generator as a parameter. So test the generator, and I hit on run. And you would see that on my testing set, I have like 96% accuracy, which is also good. So this is the overall, if you want, I want to say metric, or the overall performance that I am monitoring. Now, guys, what I need you to focus on is that accuracy is not everything. So sometimes you would have like, I don't know, 98, 99% accuracy. However, your model would be not good according to specific conditions. So it is always a good practice that you should do when you are dealing with a classification problem, not to monitor only accuracy. No, just look at how your model is performing on different sets. So in my case, for example, I have two sets, right? I have, sorry, two classes. So I need to be monitoring how well my model is doing on predicting normal patients, and how well is my model doing on predicting COVID. So take subclasses and see how your model is performing on each of them in order to see if your model is really good. Because sometimes you might get, if you want, you might get biased a bit by the accuracy, because the accuracy does not always tell you if your model is doing good. In our case, it is, because the conditions are already good. And you have already a balanced data set. But in real life, no, this is not always the case. And this is why you should be doing what I'm saying. Now, in order to plot what I call a confusion matrix, if you don't know the confusion matrix, when we plot it, I will explain it, so don't worry. In order to plot my confusion matrix, I need to have two things. I need to have, for each of the images in my testing data, I need to have the true label of it, whether this is for a COVID-19 infected patient or for a non-infected person. And I need to be getting the predicted data. So how did my model predict this particular image? So I need two things, okay, for each of these images. So what I need to be doing is that I need to be using the model.predict function. This model.predict would predict for me, for each of the images that my testing generator is going to have, the specified predictions here. Okay, so let me test generator. Okay, here I am predicting. Okay, so the testing generator is actually taking my data from the testing directory, and it is predicting for each of them what are the corresponding predictions. And now, actually, what is happening is that these predictions are going to be something between 0 and 1, right? Something between 0 and 1. So what I need to be doing is that the ones that are higher than 0.5 are going to be considered as 1, and the ones that are lower than 0.5 are going to be considered as 0. And to do this, I just write this line of code. So predictions higher than 0.5. What does this give me? This would give me an array, if you want, of predictions, and these predictions are going to be either true or false. Okay, so if it is higher than 0.5, it's going to be true. If it is lower than 0.5, it's going to be false. Okay, now in my case, I'm not interested in the true or false. So I am interested whether these are 0 or 1, and this is why I need to be changing this to an integer. Okay, so I need to be changing these Boolean things to integers, and this is why what we need to be doing is to use the predictions.as type int, and this would just change what you had to an integer. So this would change the Boolean variables that you had, the true or false. It would change them to integers, where true would become 1 and false would become 0. Let me just run this cell to see what we have. Okay, so now just let me actually show you the predictions. What did we have? So this is the array of predictions that we had. Okay, so as you can see, it's an array having for each image the corresponding predicted label. Okay, now in order to plot the confusion matrix, I don't need just this. I need also the ground truth label of the image. So each image, is it really a COVID-19 infected, or is it really normal? And in order to do this, we have what we call the test generator dot classes. Okay, let me just take it. Okay, so these are the classes here using this classes property. Actually, I can access the classes for individual images. Okay. However, what you should note is that these classes are present in an unshuffled manner. Okay. So as you can see, the zeros start and then the ones start. And this is why, while defining my testing generator at the beginning, I put be shuffled to false, so that my predictions would be according to the image in an unshuffled order. Because if I shuffle them, I cannot leverage the existence of this classes property in order to be comparing them. Okay. I hope things are clear. Now, in order to plot this confusion matrix, I'm going to be passing the two parameters, which are the true labels that I got from this particular line of code. So let me copy it and paste it right here. This is the test generator.classes. And I'm gonna be also adding my predictions, right? So the predictions are, what did my model predicted? That's what did my model predict actually? Okay, so here I create my confusion matrix, which I'm going to explain in a bit, and then I am plotting it using a heat map. A heat map, guys, is just if you want a matrix. However, it is plotted in colors. Okay, so here you can see that I have a matrix plotted in colors, where I have here high numbers, for example, 23. It is a high number, and the colors that are a bit dark are referring to low numbers. Let me explain a bit what is this confusion matrix and how does it really help me. So the confusion matrix is made of two parts. Here I have the predicted part, okay? Here I have what I predicted, and here I have the true part. Excuse my handwriting, by the way. Okay, so what does this mean? This means that here I have 23 images that I predicted as 0, and they were actually the 0. Okay, so I predicted negative, and the image was negative 23 times, and these are the true negatives. Okay, that's the first thing. Now, if I move to the opposite direction here, I have 25 images where I predicted 1, and the actual label was also 1. So this means that I predicted positive and my true label was already positive. And this means that I have 25 true positives, which is good. So this means I did not do a mistake, actually. Now here, if I need to see, for example, this here, so I have 0 times where I predicted 1 and the actual label was 0. Okay. So I did not misclassify, if you want. I did not misclassify any normal thing. And here, if you look at it, I predicted 0 and the actual label was 1 in 2 cases, for example. Okay, so this confusion matrix, it just tells you where is your model making wrong assumptions or wrong predictions, you know? So yeah, that's the goal out of it. So you have like 50 samples, you have some errors, you need to be spotting where these errors have occurred. That's the only thing behind it. Okay. So yeah, any questions so far? By the way, we still have one part and we're done. Okay, we still have one part where we'll be just seeing some images and seeing some predictions based on them, and just that. Do you have any questions? Anything is unclear that you need me to repeat? Can we know which image we got it wrong in our prediction? Actually, also, this is a great question. That's something that I would be advising you by the end. Okay, so I would be telling you that let me keep it till the end. Okay, now what we will be doing is that we would be seeing some images. Okay, so we'd be sampling random images. If we have luck, these random images would be the wrongly classified to see them. But if they're not, actually what we usually do is that we just really observe each of our images and see the corresponding prediction in order to see why did our model did a wrong prediction? Why did it do a misassumption, if you want? Okay, because accordingly we would be knowing how can we retrain and how can we, if you want, make our model better. You know, this is what we call the error analysis. I will be talking to you about it by the very end. after passing over this point. Okay, so I assume everything is clear. Let me just pass to this part. So as I mentioned, in this part, what I need to be doing, guys, is that I need to be seeing the predictions of my actual model. So I have a model, I have a testing set. I need to be seeing some images that I provide as input for my model, how it would predict them. Okay, this is the goal out of it. So now, one thing that I should be doing is that I need to be specifying the batch size of this test generator that I have specified before. The batch size is going to be 1. And this is because I need to be taking one image at a time. Okay, so the test generator, it just takes your images from the directories, however, as batches. Okay, so what I need to be doing is to specify that this batch size that I need to be taking is 1, so that I could take one image. And I'm going to be shuffling them so that I can have like whatever image in whatever directory, okay, to have some randomness inside of the process. Now, after it, I need to be taking an image from this test generator. Okay, so this test generator, again, I repeat, it just takes some images from the directories that you have provided while defining it. Now, how do I get a part? Actually, let me run this cell before I forget. Okay. Now, how do I get a particular image? So I just write test_generator.next. The test_generator.next, it would actually return for me the next batch. Okay, each time I call test_generator.next, it would give me a new batch. In my case, I am setting the batch size to 1, and this means that it would be giving me an image. Each time I call the test_generator.next, it would be giving me an image. It's like a pointer, exactly, Ahmad. So iterator, more specifically. So it is just iterating over the images, and each time I call the next, it would give me another image, another batch. And in my case, it's going to be an image. So let me, for example, run this. Okay, now I have an image variable. Let us just take a inspect what's inside of this image variable to get a better understanding. Let me print it. So you can see that here I have a particular array, and this array actually, guys, is the actual image. Okay, is the pixels that are inside of this image. Okay, this is the first thing inside of it. The next thing is here another array which is holding the number 1. The number 1, it indicates that this is a COVID-19 infected person. Okay, so this is the true label. So if I need to, let's say, I'm gonna here add another code. If I have the image 0.shape, what does it give me? It's gonna give me 1, which is my batch size. In my case, I have one only picture inside of my batch size. And here are the dimensions of my image, which we agreed on before. Okay, so this is just to prove to you that this image of 0, it gives you the actual image. Now, if I need to get the real label of this image, I just call the image 1. Okay, so if I write here, for example, image 1, it's gonna give me the 1. Okay, because 1, this means that this image belongs to a COVID infected person. Okay, now I have the image and I have the actual label. I need to see how will my model predict it. Okay, what is gonna be my model prediction? And for this reason, I'm gonna be generating a prediction calling the model.predict, and I'm gonna be passing here the image 0. The image 0 holds the image, as I mentioned. And I'm gonna be showing this image just for the sake of seeing if my model did wrong, for example, why is it doing wrong? So is there anything that I can explain about it? And this is something that we need to be considering. So image 0, 0. Why am I adding this 0 here? I'm adding this 0 just to remove this dimension. Okay, so this would give me the 128 by 3, so that it would be able to be visualized. And then I am writing in the title the prediction that I obtain along with the true label. And how do I get access to the true label? I get access to the true label by using the image of 1. And let us run this cell to see what do we obtain. So in our case here, the predicted label was 1 and the true label was 1. This is for one image. Okay. Now, what we do is that we can do this for several times. Let me actually remove this code cell here so that things would be less noisy. Okay. Okay. Now, if I call the image generator.next another time, it would give me another image. I run this cell again, it would give me another image along with its prediction. So here, for example, the true label was 0, and the predicted label that we have predicted, it is also 0. Okay, so we can do this, so on and so forth, to get more images and get to see. So, okay, for the person who asked me about this, so here, for example, you can see that we actually predicted that this person has COVID. However, this person did not have COVID. Okay, the true label was 0. However, we predicted it as 1. If we just look at this image, we can see that it is a bit like blurry at sometimes. For me, it is always confusing, by the way. But the goal of this, and this is actually what I need to tell you. So the goal of this is to do some kind of error analysis. And how do we do error analysis? We see where our model did false assumptions. Where did our model predict things in the wrong fashion? Okay. And accordingly, we would know how to improve our model. So for example, if sometimes it might happen that you would see that this particular image, for example, your model did not predict it in a good way. However, this image, if you look closely, you did not have something very similar to it in your training set. So you did not train your model on something to be able to recognize it. And this means that, for example, you need to get more data in order to make your model spot it the next time. You know, so this kind of error analysis, guys, that we do is something very essential because it actually drives your next step. It tells you how you can okay. Yeah, he's smoking a lot. So this error analysis, guys, it actually tells you what are the things that you need to change related to your data, by the way. Okay, so it helps you know what is going to be your next step in order to improve your model. Because trust me, guys, no model you do it and that's it. No, you always need to be monitoring, improving according to what is the input that your model is receiving. And this is why it is always a good practice to see how your model is doing on individual samples that it is receiving, and accordingly know what you would want to improve. For example, in my case, maybe I would add more images that have maybe the lightning a bit more for the people that are normal, okay, in my training set. And this means that maybe for later it would be able, my model, to classify this kind of particular image, for example. So this is it from my side. We finished the workshop, guys. I hope you had a great time. Now, before I wrap it up, do you have any question, anything? Was it easy? Was it hard? Did you understand? Was there something too technical for you? I don't know. Whatever you have, just feel free to tell me. For me, I am finished. If I have a big data set, is there any solution than moving on each image? Look, actually, you don't, when we do, for example, error analysis, you do it on your testing set to see on the test set how it is really operating. And your test set is usually small, okay? It's usually like not gonna be that big. You train on something. Now, it is always a good practice to train on a big data, if you want, so that your model would learn a lot. And you would be evaluating it on a subset. And when we do the error analysis, we usually do it on the evaluation. And yeah, so usually you need to see the prediction, because otherwise you're not going to be able to spot what was the problem. And if you're not able to spot what was the problem, you're not going to be able to find a solution. You know, in order to find the solution, you need to see the actual problem. To see the actual problem, you need to see the image that caused the problem. Maybe the image by itself has a problem, you know? So it doesn't always mean that your model has the problem. So guys, here there is something. So usually when we talk about data-centric AI, we talk that the model is only as good as the data that it is trained on. Okay, so if the data that I am training my model on is good, this means that my model is good. If the data that I have is not good, this means that my model won't be learning anything. And when my model is not doing anything, it's just because of the data that it is receiving. And always my goal to improve my model is not to, let's say, increase the number of layers, change the number of epochs. These are amazing things that you can always do, definitely. However, what you should always be looking to do is to look what is the data that caused your model not to perform well. Because just for your information, a very simple model would perform amazingly well with good structured data. When you have a good data and you feed it to a simple model, your simple model would do very well, and it would maybe outperform some more complex models that are dealing with your data. I don't know if I answered your questions, your question, but I hope I did. So yeah, what you need to be always doing is to monitor the data set and monitor what actually caused the problem. So thanks a lot, guys. Thanks a lot for your feedbacks. I really appreciate it, and I hope that you enjoyed the workshop, and I hope that you learned something new, regardless of whatever backgrounds that you already have. Thank you so much for attending. I personally had a great time, and yeah, I can say that see you in the next event.
Thank you, Fouad. It was a very useful and interesting workshop. Now I will be sending the Gather Town link so we can all connect there. You can also join us, Fouad.
Yes,
the participants want to connect with you.
yes.
Okay, so we'll see you again at 12:10 p.m.